Namaste. Now portraying I, JVWU Muskan Kumari from the Department of Science and Technology, and I am working here as an assistant professor in JVWU University and Faculty of Education. Okay, so today our session, which I will discuss with you, that's name is Q in Java, which is the topics under your basic introduction to the wave intelligence, data science, rules, isn't it? Okay, so now I will discuss these topics today with you via sharing some points. Okay, so please hold my minute. I'm just saving that. Okay, so this one is the part Q in Java. So I think you all well know about it that a queue can be defined as an ordered list that enables insertion options to be performed at one end called rear and delete operations to be performed on the other end that's called front. Okay, so there are two in the queue. One is known as the rear for the insertion and one is known as front for the deletion of the elements. Okay, queue is referred to with the first in first out. Whatever the elements come first, you will remove that elements first. Isn't it clear? So for example, people waiting in a line for a rail ticket from the queue. In this example, you can easily see that the person who came first, they will take the ticket firstly and discard from that ones, displaces from that place where he was standing for waiting for the ticket. Clear? So this is the queue, structure of the queue here. This is called the front and this is called the rear. You are inserting the elements from this one, that operation is known as in queue, and deletion of operations from this one, that one is called DQ. Whenever you insert the elements is coming here and they are shifted towards the left side, okay, right to left. The application of the queue. Application due to the fact that queue performs action on the first in first out basis, which is quite fair for the ordering of actions. There are various application of queues which is discussed below, like queue can be widely used as the waiting list for single shared resources. There is only one resource and for that resources multiple process can be wait or the list are waiting for that, like the printer disk CPU, isn't it? Like printer, in printer you can see that one by one pages are going to be printed, isn't it? So the first commands which you have gave to the printer, that will print that documents first, and after that whatever the commands is given by the users, they are just form a queue and then printing one by one as per scheduled in the queue. Okay. Now, queue are used in asynchronous transfer of data where data is not being transferred at the same rate between two processes. For example, pipes, file input output sockets. Clear? Now, queue are used as buffers in most of the applications like MP3, media players, CD players, etc. Queue are just used to maintain the playlist in media player in order to add and remove the items or song from the playlist also. Queue are used to in operating system for handling the interrupts also. So there are two fundamental operations which is performed on a queue. First is in queue, which is used for inserting the elements at the rear end of the queue and it returns void. DQ, the DQ operation performs at the deletion of elements from the front end of the queue, and pick is known as the third operation that returns the elements which is pointed by front pointers in the queue but doesn't delete it. Okay, only uh, points the elements. And queue overflow is full. When the queue is completely full, then it shows the overflow conditions, and queue underflow, when the queue is empty, no elements are in the queue, then this condition is known as the is empty. Okay. So now a queue is represented as a container opened from both sides in which elements can be queued and from one side and dequeued from the another sides, which is shown as the above example figures. Now implementation of the queue. What is the implementation of queue? How can you implement the queue? We can implement the queue in the for sequential allocations and linked list allocations. Okay, so sequential allocations. The sequential allocation in a queue can be implemented using an array, and this linked list allocation in queue can be implemented using the linked list. Okay, so what are the uses of you? What are the use case of queue? Suppose there are various time queue are used in the data structures. The queue data structure mainly used where it is shared the resources where and to serve the multiple requests but can serve a single request at a time. In such case, we need to use the queue data structure for queuing of the request. And suppose we have a printer shared with various machines in a network, and any machine or computer in a network can send a print to the printers, but the printer can serve a single request at a time, isn't it? The printer can serve a single request at a time. A printer can print a single document at a time, whatever you have commands given them as a multiple commands line. If a request are available in the queue, the printer takes a request from the front of the queue and serves it. Okay. Now the processor in a computer is also used as a shared resources. There are multiple requests that our processors must execute, but the processor can serve a single request or execute a single process at a time. Therefore, the process are kept in a queue or executions. In a queue for the executions. Here are the types of the queue. There are four types of queue. First is linear queue, then your circular queue, and many more queues we will discuss in the later. So firstly I will discuss only two queue, linear queue and again. In linear queue, insertion takes place from the one end while the deletion occurs from the another end. This is the basic properties of the queue. The end at which the insertion takes place is known as the rear, and the end from where the deletion takes place is known as the front end. It strictly follows the FIFO rule, and the linear queue also represented as shown in the figure. This one, you are inserting the elements. It means deleting the elements from the front end and insertion of the elements from the another end, that is called the rear, isn't it? Whatever the elements are, suppose there are the four sides of the array, this one, and this is the formation of the queue where you are inserting the elements from this one's rear points, rear sides, where you have inserted firstly 10, then 20, then 30. So now I want to delete suppose 20, then firstly I have to delete 10, then this is shifted towards this one position, then I deleted the 20. So this ever diagram, so the elements are inserted from the rear in, and if we insert more elements in the queue, then rear value gets incremented. Rear equals to rear plus 1 on every insertion. If we want to show the deletion, then it can be represented as this type. This element is vacant, position vacant, here is the 20 and this one is the 30. Now it becomes the front, to which elements I have to delete it, isn't it? So this is the basic parts of that one. And the major drawback of this linear queue is the insertion is done only when from the rear end. And if the first three elements are deleted from the queue, we cannot insert more elements even though the space is available in the linear queue. Now if we talk about the circular queue, then you can see here is a circular queue. All nodes are represented as circular. It is similar to the linear queue except the last elements of the queue is connected to the first element. It is known as the ring buffer, isn't it? Because this is the formation of a ring. All the ends are connected to one another end, and this end is connected to this one another. The circular queue can be represented as like The drawback of occurs in the linear queue is overcome by using the circular queue. If the empty space is available in a circular queue, the new elements can be added in an empty space by simply incrementing the value of relay. Now the priority queue. What is the priority queue and D queue? There are four types. Firstly, linear queue, circular queue, priority queue, D queue. Priority queue is another type of special queue data structure in which elements has some priority associated with it. Based on that priority of the elements, elements are arranged in a priority queue. If the elements occur with the same priority, then they have served according to the FIFO principles also. Isn't it? In priority queue, insertion takes place on the basis of arrival, while the deletion occurs on the basis of the priority. Isn't it? Insertion of elements based on the arrival time and the deletion of is based on the priority. Now comes to the DQ. What is the DQ? Both linear queue and DQ are different, as the linear queue follows the FIFO principle, whereas DQ follows the FIFO principle. Don't follow the FIFO principle. In DQ, the insertion and deletion can occur on the both ends. Is that clear? In linear queue, you are using one side for the insertion and another side for the deletion. But in D queue, you can insert and delete items from both sides, front and rear both sides. Okay, so now this is the basic session of your queue. I hope you will better understand this session. And in case if you have any problem regarding this session, then please share your query with using the comment box, through which I can solve that query in the next session, isn't it? And please be prepared regarding all the questions, possible questions from this session. That what is the priority queue? Why we are using the circular queue? What is the difference between the circular and linear queue? How we can perform the operations in the queue, isn't it? So please be prepared and also learn these sessions from multiple standard books like the data structure book, and also use the multiple website, online website, through which you can get more valuable and knowledgeable information regarding this session. Okay, thank you.